Hello everyone, welcome to the new series on 8085 assembly language programming. So here I'll be showing you how we can simulate 8085 program using online simulator. So I'm using this Sim 8085. So if you see this, there are different sections here. First one, the main is the program tab. Here you have a different resistance of 8085, that is the accumulator and the flag register. Then you have your PC pair, that is a B register and C register. This is D and E register, H and L register. This is the stack pointer, and this is the program counter. Here you have various flags, starting with the sign flag, zero flag, auxiliary carry, parity, and the carry flag. These are the various interrupts here. In this video, I'll be just telling you about how to use the move instruction, addition and subtraction. So starting with the move instruction, as you know that in 8085 we have a general purpose two move instruction. One is MOV and second one is immediate move instruction, it is MVI. So let's say I'm using MVI A, 05H. In this case, what is happening? 05 is transferred to the accumulator. If I want to use a register transfer instruction, I can go for MOV B, A. So in this case, whatever is there in accumulator will be transferred to register B. And to end the program, I have to write at last called HLT. Now I have to simulate this program. So I have to go here in the load and run. And the program is successfully simulated. You can see here A will have 05H and B will also have 05H. Now let's add some more instruction to this. If I want to add this B and A content, I can use a register add instruction, which is again generally we have two, adding a register and directly adding the number to the accumulator. So when I say add B, what is happening here? When I say add B, the content of B is added to the content of accumulator and the answer is stored in the accumulator. So in this case, what will happen? B is having 05H, A is having 05H. So the addition 05 plus 05, that is 10 in decimal. If I convert that in hexadecimal, it will be 0AH, which will be stored in the accumulator. So when I run this code, you can see the changes. A is 0AH now. Now again, if I add the second addition instruction, that is ADI, and I can directly add 05H to it. So now what will happen? 05 will be added to this 0AH and answer will be stored in the accumulator. So the 05 plus 0A will be your 15. 15 in hexadecimal is 0FH. You can see the difference here now. The addition, answer of addition is reflected in the accumulator. Now going to subtraction, again we have two instructions. One is SUB. If I say SUB B, what will happen? This B data will get subtracted from the accumulator and the answer will be stored in the accumulator. So it will be 0F minus, what is there in B? 05. 0F minus 05 and the answer, that is 0A, will be stored in accumulator. So when I run this code, you can see the changes which is made here. Now the last instruction is SUI. Let's say I'm taking 05H only. When I'm doing SUI 05H, this 05 will be subtracted from the accumulator and the answer will be stored back to the accumulator. So the answer will be 05H. Now if I want to move this data, move the accumulator data in H register. So I can write here move H, A. So this answer will be transferred in H register. So that's it for today. In the next video, I'll be taking up the other instruction, that is increment, decrement, and so on. Thank you.